Let's go over this question together. A solution of sodium bromide, NaBr, is prepared by dissolving 6.27 grams of the salt in 1 kilogram of water H2O. What is the freezing point of the solution? Knowing that the freezing point of pure water is 0 degrees Celsius at 1 atmosphere pressure, and the molal freezing point depression constant for water is 1.86 degrees Celsius per molar. First, let's summarize the information given to us and what we need to find. We need to find the freezing point of a solution, and the solution is made by mixing 6.27 grams of NaBr and 1 kilogram of water. And we also know the TF, or freezing point, of pure water is 0 degrees Celsius. And we know the freezing point depression constant for water is 1.86 degrees Celsius per molar. So first, let's talk a bit about what happened when a solute is added to the solvent and how that affects the freezing point. When a solute is added into a solvent to create a solution, there will be a decrease in the freezing point, and therefore freezing point of solution is going to be equal to freezing point of water minus delta TF, which is the freezing point depression. We know that the freezing point of water is going to be 0 degrees Celsius, and the delta TF, the formula, is going to be I times Kf times small m. And let's talk about the individual component in that. So I is the Van Hoff factor, Kf is the freezing point depression constant, and the small m is molality. So now let's talk about what is Van Hoff factor. So Van Hoff factor I is the number of particles in solution per formula unit. So for example, for NaCl, the Van Hoff factor is going to be 2 because NaCl dissociate into 2 particles, Na plus and Cl minus ions. So therefore, that's 2 particles in solution per 1 formula unit of NaCl. And another example would be for sucrose. The Van Hoff factor is going to be 1 because sucrose does not dissociate into ions like NaCl. Therefore, there will be just 1 particles of sucrose per 1 formula unit in a solution. So applying that to our case, for NaBr, the Van Hoff factor is going to be 2 because NaBr dissociate into Na plus and Br minus ions. Therefore, that will be 2 particles in solution per 1 formula unit of NaBr. So back to our case. So we know the Van Hoff factor is going to be 2. We know the freezing point depression constant given to us is 1.86. And now we have to calculate molality. The formula for molality is going to be moles of NaBr divided by kilograms of water. So now let's calculate moles of NaBr. So formula for moles of NaBr is going to be mass of NaBr divided by molar mass of NaBr. Substitute numbers in, that's going to be 6.27 grams divided by 23 plus 79.9. That is the molar mass of individually of Na and of Br, so combined, that will give us molar mass of NaBr, and we'll get a value of 0.061 moles. So now, to calculate molality, that's going to be 0.061 moles divided by 1 kilograms of water, which is going to give us 0.061 molar. And now, finally, let's calculate delta TF, that's going to be 2 times 1.86 times 0.061 to give us 0.227 degrees Celsius. That's the freezing point depression. And now, for the freezing point of solution, again, that's going to be the freezing point of water minus the freezing point depression, delta TF. So that's 0 degrees Celsius minus 0.227 degrees Celsius, which is going to give negative 0.227 degrees Celsius. That's going to be the freezing point of this solution.